If the standard calculation method outlined in section 220.82 of the National Electrical Code reveals a calculated load surpassing 100 amps, then the optional calculation method detailed in section 220.30 becomes available for determining the permissible reduction in apartment feeder sizes. Utilizing section 220.30, the apartment feeder sizes can be reduced to 60 amps, 70 amps, 80 amps, or 90 amps, contingent upon the results obtained through the optional calculation method. The NEC provides different methods for calculating the electrical load of a building or dwelling unit. These methods, the standard and optional calculations, are used to determine the appropriate size of the service entrance conductors, feeders, and overcurrent protection. Standard calculation, as covered in Article 220 Part 2, is generally used for dwelling units. It involves calculating the general lighting load, small appliance circuits, laundry circuit, and fixed appliance loads. The general lighting load is calculated based on the square footage of the dwelling. Small appliance circuits are calculated at 1500 volt amps each, and the laundry circuit is also calculated at 1500 volt amps. Fixed appliance loads are calculated based on their nameplate ratings. For dwelling units, a demand factor of 3 volt amps per square foot is used for general lighting and general use receptacles. 220 amp small appliance circuits are required for the kitchen and 120 amp laundry circuit is required. The NEC requires these circuits to be calculated at 1500 volt amps each. Electric ranges and cooking appliances are calculated based on Table 220.55. For example, if the dwelling unit has a single range rated at not over 12 kilowatts, the demand factor is 8 kilowatts. For other appliances, such as dishwashers, disposals, and water heaters, the nameplate rating is used. Air conditioning and heating loads are calculated separately and added to the total load. After calculating all the loads, the total demand load is determined by applying demand factors, as permitted by the NEC. Optional calculation, as covered in Article 220 Part 3, is another method used for determining the service or feeder size for a dwelling unit. It's often used for new construction or when the existing service is being upgraded. This method allows for a lower demand factor to be applied to the total calculated load. The optional calculation method for dwelling units is outlined in section 220.82. This section provides a table of demand factors that can be applied to different types of loads, such as heating, air conditioning, and cooking equipment. To use the optional calculation method, you must first determine the total connected load of the dwelling unit. This includes the loads for lighting, small appliance circuits, laundry circuit, cooking equipment, heating, and air conditioning. Once you have determined the total connected load, you can apply the demand factors from section 220.82 to calculate the total demand load. For example, the first 10 kilowatts of heating load can be calculated at 100% demand factor, and the remaining heating load can be calculated at 40% demand factor. Similarly, the first 8 kilowatts of cooking equipment can be calculated at 80% demand factor, and the remaining cooking equipment can be calculated at 65% demand factor. Air conditioning load is calculated at 100% demand factor. The total demand load is the sum of the demand loads for heating, air conditioning, cooking equipment, and other loads. The service or feeder size is then determined based on the total demand load. It is important to note that the optional calculation method is only permitted in certain situations, such as when the dwelling unit has electric heating, air conditioning, and cooking equipment. It's also important to consult with a qualified electrician or electrical engineer to ensure that the service or feeder size is properly calculated and installed. Section 220.30 provides an optional calculation method for multifamily dwellings. It is used to determine the feeder or service load for apartment buildings or other multifamily dwellings. This method allows for a lower demand factor to be applied to the total calculated load. Firstly, calculate the total connected load of all the dwelling units in the building. This includes the loads for lighting, small appliance circuits, laundry circuit, cooking equipment, heating, and air conditioning. Secondly, apply the demand factors from Table 220.84 to calculate the total demand load. This table provides demand factors for different types of loads, such as cooking equipment, heating, and air conditioning. The demand factors vary depending on the number of dwelling units in the building. Thirdly, determine the feeder or service size based on the total demand load. The feeder or service conductors must be sized to carry the total demand load, as well as any additional loads, such as common area lighting or elevators. It is important to consult with a qualified electrician or electrical engineer to ensure that the feeder or service size is properly calculated and installed. Other considerations when determining the feeder or service size include voltage drop, conductor ampacity, and overcurrent protection. Voltage drop is the decrease in voltage that occurs along the length of a conductor due to its resistance. The NEC recommends that voltage drop not exceed 3% for feeders and 5% for branch circuits. Conductor ampacity is the maximum amount of current that a conductor can safely carry without overheating. The ampacity of a conductor is determined by its size, insulation type, and installation method. Overcurrent protection is provided by circuit breakers or fuses. These devices are designed to protect conductors and equipment from overloads and short circuits. Circuit breakers and fuses must be sized to protect the conductors they supply. The ampacity of the overcurrent protection device must not exceed the ampacity of the conductor. In addition to the NEC requirements, local codes and regulations may also apply to the installation of electrical systems. It is important to consult with the local authority having jurisdiction to ensure that the electrical system is installed in accordance with all applicable codes and regulations. The application of demand factors allows for a reduction in the calculated load based on the assumption that not all loads will be operating at the same time. The specific demand factors that can be applied vary depending on the type of load and the number of dwelling units being served. For example, the demand factor for household cooking appliances in a multifamily dwelling is lower than the demand factor for a single-family dwelling. This is because it is less likely that all of the cooking appliances in a multifamily dwelling will be operating at the same time. When using the optional calculation method, it is important to carefully consider all of the applicable loads and demand factors. The calculation must be performed accurately to ensure that the feeder or service conductors are properly sized. It is also important to consider any future load growth when determining the feeder or service size. A feeder or service conductor should be sized to accommodate any anticipated future loads. If the standard calculation method reveals a calculated load surpassing 100 amps, then the optional calculation method becomes available. The optional calculation method is designed to provide a more realistic assessment of the actual load requirements of a building or dwelling unit. This method takes into account the diversity of loads and the likelihood that not all loads will be operating simultaneously. By using the optional calculation method, it may be possible to reduce the size of the feeder or service conductors, which can result in cost savings. It's worth emphasizing that electrical calculation should be performed by qualified professionals. Understanding the NEC and its application requires a solid foundation in electrical theory and practice. Mistakes in electrical calculations can have serious consequences, including fire hazards and equipment damage. Competent electrical contractors and engineers will be familiar with the different calculation methods and will be able to determine the appropriate size of the feeder or service conductors. Moreover, they will ensure that the electrical system is installed in accordance with all applicable codes and regulations. Reducing the size of the apartment feeder based on the optional calculation can be a cost-effective way to design the electrical system for a multifamily dwelling. The savings in materials and labor can be significant, especially in large projects. However, it is crucial to ensure that the reduced feeder size is still adequate to handle the actual load requirements of the building. The NEC provides guidelines and requirements for determining the appropriate feeder size, and these guidelines must be followed carefully. The NEC contains provisions for calculating the size of electrical services and feeders for various types of buildings, including apartments. These calculations ensure that the electrical system has sufficient capacity to safely handle the anticipated loads. The NEC provides two main methods for calculating electrical load: standard calculation and optional calculation. The standard calculation is generally more conservative and results in a larger service or feeder size. The optional calculation is more detailed and takes into account various factors that can reduce the overall load. The optional calculation method is often used for large apartment buildings or multifamily dwellings where the diversity of loads can result in a significant reduction in the overall demand. By applying demand factors to different types of loads, the optional calculation method can provide a more accurate assessment of the actual load requirements of the building. This can lead to a smaller service or feeder size, which can result in cost savings. When using the optional calculation method, it is important to carefully consider all of the applicable loads and demand factors. The calculation must be performed accurately to ensure that the electrical system has sufficient capacity to safely handle the anticipated loads. The NEC provides detailed instructions and guidelines for performing electrical calculations, and these instructions must be followed carefully. If the calculations result in a feeder size of 60 amps, 70 amps, 80 amps, or 90 amps, then these feeder sizes are acceptable, provided that the calculations are performed in accordance with the NEC and all other applicable codes and regulations. The feeder conductors must be sized to carry the calculated load, and the overcurrent protection device must be sized to protect the conductors from overloads and short circuits. In addition to the NEC requirements, local codes and regulations may also apply to the installation of electrical systems. It is important to consult with the local authority having jurisdiction to ensure that the electrical system is installed in accordance with all applicable codes and regulations. The NEC is a comprehensive set of standards that governs the safe installation of electrical systems. It is updated every 3 years to reflect changes in technology and industry best practices. It is important for electrical contractors and engineers to stay up to date on the latest edition of the NEC to ensure that their installations are safe and compliant. The NEC provides detailed requirements for conductor sizing, overcurrent protection, grounding, and other aspects of electrical installations. These requirements are designed to protect people and property from electrical hazards. The NEC is a complex document, and it can be challenging to understand and apply. It is important to have a thorough understanding of electrical theory and practice to properly interpret and apply the NEC requirements. The NEC is not a substitute for sound engineering judgment. It is important to consider all of the relevant factors when designing and installing an electrical system. These factors include the type of building, the occupancy, the anticipated loads, and the environmental conditions. The NEC provides minimum requirements for electrical safety. In some cases, it may be necessary to exceed these requirements to ensure a safe and reliable electrical system. Electrical safety is of paramount importance. Electrical hazards can cause serious injuries or even death. It is important to take all necessary precautions to prevent electrical accidents. Electrical work should only be performed by qualified individuals who are trained in electrical safety procedures. These individuals should be familiar with the NEC requirements and should have the necessary skills and knowledge to perform the work safely. Electrical systems should be inspected regularly to identify and correct any potential hazards. Regular maintenance can help to prevent electrical accidents and ensure that the electrical system operates safely and efficiently. Electrical safety is everyone's responsibility. By following safe electrical practices, we can help to prevent electrical accidents and protect ourselves and others from harm. The optional calculation method in Section 220.30 offers flexibility in determining feeder sizes for apartment buildings. The ability to potentially reduce feeder sizes to 60 amps, 70 amps, 80 amps, or 90 amps when justified by the calculation can lead to significant cost savings in materials and installation. However, it's absolutely vital to adhere strictly to the NEC guidelines and local regulations to ensure a safe and compliant electrical system. Consulting with qualified electrical professionals is crucial to ensure accurate calculations and proper installation. Their expertise will help in navigating the complexities of the NEC and in making informed decisions about the electrical system design.